Tomorrow will be better. A rock weighs 100 Newton in air. When submerged in water, it displaces 5 liters of water. Find its apparent weight in water. Dear friends, let me start by explaining the context of this question. We've all experienced the fact that objects always feel lighter when they are submerged in a fluid, notably in water. But most of us don't know the reason behind this. Now, whenever an object is submerged in water, there's a force in water which resists the downward movement of that object into that water. And that force is what we call the buoyant force. It is this force which is responsible for making that object feel lighter than in real life. Therefore, for us to calculate the apparent weight, which is actually like the false weight of this object when submerged in water, we have to subtract that buoyant force from the real weight of this object in air. Follow me, dear friends. Solution. The most relevant formula to calculating this is apparent weight, APP, is given by the weight in air minus the buoyant force. So how do we calculate the buoyant force? By definition, buoyant force is given by the weight of the displaced liquid, in this case, which is water. So it will be the mass of the displaced water times the acceleration due to gravity. Unfortunately, we do not have the mass of the displaced water. What we have here is the volume of the water which has been displaced. So how do we use volume to get the mass? Or how do we go about this? We know that density by definition is mass per unit volume. So if we want the mass when we have the volume, we just multiply this. Therefore, we will say, the buoyant force can also be expressed as, instead of mass now, I will write the density times the volume, which represent the mass, and now times gravitational acceleration. And if you do this well, let me punch it numerically, we will have the density of water, which is 1000 kilograms per meters cube. Now the volume here has been given in liters. We have to bring it down to meters cube in order for the units to be homogeneous. So how do we convert liters to meters cube? By dividing by 1000 and then times acceleration due to gravity. Let's take it as 9.8. If you do this well, we should have 49 Newton approximately. What do we do next? We are almost done. Therefore, this apparent weight apparent will be equal to the 100 Newton, the weight in air, minus the buoyant force, which is 49. And if you do this well, we should end with 51 Newton, because weight is also a force. So it should be expressed in newtons. Tomorrow will be better.